Yo guys, that kid from Morgo right back at you, and today we're going to be going over Meso compounds from chapter 5. So what are Meso compounds? Basically, Meso compounds are identical compounds within stereochemistry that don't look identical, but they are identical. So you know the good old classic formula 2N to determine how many stereoisomers there are? Well, meso isomers can kind of tell you to go screw off because that's not going to work with meso compounds. So for meso compounds, we have to account for this because if you have two stereocenters, for instance, and you do the formula 2 to the second, you should have 4. However, if there's a meso compound, you got to take one of those out. So you actually only have 3. Wow, that's kind of inconvenient, but welcome to organic chemistry. So let's move on from this. How do we identify meso compounds? Well, there's a few things you should know. They have R and S configuration. They have at least 2 stereo centers. And my handwriting's kind of bad today, sorry guys. And they have an internal plane of symmetry. So keep these things in mind when you're looking for meso compounds, and you'll be so happy. Okay, so let's do some practice problems to use these rules. Here we go. Let's draw a compound real quick. And let's say it's chlorine and chlorine. So, is this a meso compound? Well, we have 2 stereocenters. And I highly recommend, if you don't know how to identify stereocenters, to go back to my previous video because I'll clear that up for you right away. And we also, look here, have an internal plane of symmetry. So there definitely is a meso compound with this molecule. So what is it? What is the meso compound? Well, let's do our little formula real quick. 2N, which is 2 to the second, which will give us 4 stereoisomers. And let's draw these 4 stereoisomers out. I'm going to draw them out in red. So, like last video, how I told you to draw these out. Start them both off in your favorite. If it's either all wedges or all dashes, just start them off like that. And then just change one thing each time. Boom, boom, boom. Boom. Boom, 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 boom. Boom. Boom, 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 boom. Boom, 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 boom. Boom, 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 boom. And then boom, 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 boom. That's a poor one, but you guys get the point. Boom, 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 boom. So we now have our 4 stereoisomers drawn out. Which one of these 4 is the same? Well, let's take a closer look at these. Which ones look the same? Well, if I try and say that these 2 are the same, I can, because they 100% are. If I flip this pancake style on its back, say this is a pancake pan, and I take this molecule and put it in here, and I flip her around, well, congratulations, it's now going to be this. Because these 2 chlorine atoms would now be pointing backwards, not forwards, if I just flipped her over. Good example of this. Let's say I had a pancake. Okay? And I had 2 spikes sticking out of this pancake. They were sticking out at me. And then I rotated this pancake. Perfect symmetry on this pancake. Let's take that into account. No bends, no angles, not one pointing out at me and one not pointing out at me. And I bent this, or twisted it, rotated her around. All that would happen is, it's the exact same thing, these spikes are now just pointing, try and draw this as best as possible, backwards. That's all that's happening. It's the same instance for a molecule that looks like this. Same exact instance. Think of these molecules as pancakes with spikes, and when you flip her, they go backwards. Now, that's not going to work for all molecules. It's not always going to be, oh, there's an internal plane of symmetry, and it's both wedges turn to dashes. Oh, that must be the Meso compound. Well, no, because you could have a molecule that looks like this. Now then, of course, once again, we know that this is a stereocenter. We know that this is a stereocenter. And we know we have that plane of symmetry. And if you don't believe me that there's a plane of symmetry, let me rotate these bonds right here for you. So watch me do this magic. I rotate those bonds, and I make a compound that looks like this. So I have my methyl group actually up here now. And now then, if I draw that line of symmetry, boom, that's perfect. That looks great. So now we know that there's a line of symmetry, there's two stereocenters, and we're not going to go into the RNS configuration in this video. I'll make another video for that, but just know that these are RNS if I have it like this. If there was a wedge here and a dash here, these would be RNS. We won't go into that configuration until next video because you don't have to worry about that for the quiz. But let's now draw out all of our stereoisomers for this. So this is our original. We'll start them both off with those wedges, and we'll just change one thing on each of these. Just change one thing at a time until we have all four. And one more, and we should have it. Okay, that's all four of them. And remember, we use that formula, 2 stereocenters, 2 squared gives you 4. So let's now see which ones are identical. Well, once again, if we look at this one and we look at this one, you're probably thinking to yourself, oh, these are 100% identical. 100% identical. Well, you're wrong. These are not identical. Okay? And I'm going to show you why. Take this one, for instance. I'm going to throw it down here real quick. Let me move this one over here. We'll deal with that one later. So say I take this right here. Follow the blue dot down here, and I'll show you why. If I rotate this bond, where the blue dot is, and I make it look like this, it would turn into something that actually looks like this. Let me draw it in red for you. So we now have, there's a methyl group here, and there's a methyl group here. We now have a methyl group pointing out at us. We'd have chlorine group down here, and it would actually be pointing down at us. So, sorry, I'm trying to draw this. It would look like this. Boom, boom, boom. Chlorine, that methyl group up here, and then we'd have our chlorine still sticking out at us up here, and we'd have that methyl group up here. So if we rotate this bond that's highlighted in red now, we get this. Now then, if we think that this one's identical, if I take this bond right here, look at where the number 1 on the screen is. We're going to work with this one now, because if you think these are identical, I'm going to prove you wrong. We're going to take this bond and rotate it, and I'm going to draw that right here. So I'm going to draw this one in blue. So now then you're going to have, let me highlight these for you just so you can have a better representation. A methyl group, a methyl group. So you're going to have that methyl group right here. You're now going to have this like this. And chlorine right here. You're gonna have chlorine down here. You have the methyl group right here. Well now then, no matter how I try and get these to line up, if you have a molecular kit, it's not gonna work. If I try and make these equal to one another, I can't. No matter how much I rotate this, they're gonna be off from one another. They're gonna be enantiomers. So I hope that makes sense to you guys. It's hard to visualize this unless you have a molecular kit. But no matter how much I try and rotate and make these perfectly fit on one another, I can't do it. I can't flip this pancake and have it perfectly line up. However, let me show you why these ones right here are identical. So we already dealt with these ones. We know that these two right here, we know carbon, we know that molecule 1 and molecule 2 are not identical. So let's take a look at 3 and 4. Isomer 3 and 4. It's your time to shine. So isomer 3, let's rotate this bond right here and see what happens. So I'm highlighting it and I'm moving it over and I'm going to draw it in blue for you. Isomer 3 right here. I'm going to move her down here. So if I rotate this bond and I draw it like this, well, look at that. They're both pointing down. That's uplifting. So they're both pointing down now. Well, let's see what happens when I do number 4 up here and I twist the bond right here. Draw that down here also right by it. Boom, boom, boom. Would you look at that? That chlorine pops out at me. Now if I put this in a frying pan, I flip it, well I can flip it right onto this one. They fit identically on one another. So these are identical. You have to think of this in a 3D space. These are 3D shapes we're dealing with on a 2D piece of paper. And you have to wrap your mind around that. It's a very visual subject. So let's get rid of these. We now know that these two right here, stereoisomer 4 and 3, are identical. And I forgot to add those methyls on, but once again, these are methyls. Even if that tries to trick you, these are carbon attached to 3 hydrogen. So we now know that 3 equals 4 for these. And we know that 2 and 1 are enantiomers. So now that we know that, let's move on. Let's do another example. Let's do another example problem. Let's see what I have here. Okay, let's say, let me give you a kind of complicated one. Let's say we have one that looks, we're going to work with a chair conformation. So, boom, boom. These are both up. So this is in axial and this is in equatorial. And then this one is in like this, down and down. And this one is in axial, and this one's in equatorial. So now then, are these meso compounds? Well, let's translate them into a 2D shape that's actually distinguishable besides just looking at them on a chair flip, 'cause that's kind of hard. So it's going to utilize some skills you've learned in the past. So let's draw this one right here. Boom, 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 boom. I have a methyl group up on 1, and I have a methyl group up on 2. And I have a methyl group down on 1 and a methyl group down on 2. Well, let's raise these. Let's take a look at this. Are these identical? Well, we already went over one of these problems in the beginning of the video. Is there a plane of symmetry? Yes, there is. Plane of symmetry right here. There's a plane of symmetry right here. These are indeed Meso compounds. They are. I 100% guarantee you they are. Now then, why are these Meso compounds? Because once again, if I flip these on a pancake, if I flip this on its back, it's going to equal this right here. If I flip molecule 1, it's going to equal molecule 2. The pancake analogy. Think of it this way. There's two spikes sticking up on this pancake. Say I flip it over. These spikes are just going to be facing down. That's all that's going to happen. That's all that's happening with these two molecules right here. You're flipping a pancake, basically. Same thing, just flipped. Let's get rid of this. Let's do one more example for you guys tonight, and then we'll call it quits. Let's go over... Well, let's actually do a review. Review the most important things you should know from this video. Stereo isomers that involve Meso compounds have to have RNS configuration. They have to have 2 stereo centers, and they also have to have an internal plane of symmetry. So if they have all 3 of these, it's probably a Meso compound. And then it's just your job to figure out which of these 2 stereoisomers. It could be more than 2 stereoisomers, it just depends. You could have 4 stereocenters and have a Meso compound. And these rules would still apply. Is there an internal plane of symmetry? Is there more than 2 stereocenters? Is it RNS configuration? If it's all that, then it's a Meso compound. And I will leave you guys with that. So, I hope you guys have a wonderful day, week, month, year, whatever it is. Just enjoy yourself.